In this video, I explain Web Content Security Policy, what it protects against, and how to assess and improve the protection in your web application. Hi, I'm Don Bowman with Agilicus, where we make any application available to any user on any device with any login without a VPN. If you're new here, be sure to click that subscribe button and read the description below for links to more information. Stick around to the end to see how we configured an Angular application's content security policy to be robust, and then how we assessed it. HTML and web applications are the dominant applications of our time. HTML was originally designed as a read-only documentation format, and over time it became rich and interactive. Many popular web applications today accept user-generated content, for example, comments or images, etc., and then they display it to other users. In addition, as the web has become more complex, sites have adopted libraries from many third parties, including ones which dynamically choose content, such as advertisements or news feeds. When you mix these things together, you create a risk. A user entering their credit card into a travel site to buy something, alongside an advertisement presented via JavaScript coming from a CDN and community comments, it's a recipe for security disaster. And yet, it's the norm. Many different tools have been created addressing this challenge, but today we will talk about the most powerful and most complex content security policy. Content security policy is a header that a website emits instructing the browser what to allow and what to deny. It's broken down by type, fonts, CSS, images, etc., and also by domain, self, inline, other websites. A strong security content policy will only allow self. This means that nothing hosted anywhere other than the source web server is allowed. However, that's not very realistic. It prohibits, for example, Google Analytics, fonts served from a CDN, etc. The risks you are protecting against with a strong content security policy are unsafe third-party code being evaluated in the page model of the browser for your website. Some pages are more sensitive than others, login pages, form submittals. However, with a modern application, a session cookie or JSON web token representing the login and permission are available on all pages. We need the content security policy to be strong everywhere. A hybrid between self and named sites is called SubResource Integrity. In this model, a signature of the content is performed. If it matches, it's allowed. This is far more flexible than trying to estimate all third-party sources. However, it can be very challenging to set it up since all libraries have to support it. If possible, use either self or SubResource Integrity for all types, and block types of type object. Do not allow unsafe insign or unsafe eval or data. An excellent resource to assess your content security policy is the Mozilla Observatory, linked below in the description. If you own and operate a web application, whether it be a static site, WordPress, or an e-commerce site, you must set up your content security policy. No exceptions. Your customer's fate rests in your hands. Be responsible. Linked in the description below is a post explaining how to use the Angular ahead of time, AOT, with the SubResource integrity and output hashing to secure it. If you do this in your build, use strongly hardened resulting package. Also linked in the description below is a post showing how I used OpenResty, which is a web application firewall, to solve a particularly sticky problem: how to use Google Tag Manager with a nonce, enabling SubResource integrity. Thanks for watching. Please remember to subscribe. Would you like to have a powerful content security policy and all the benefits of a web application firewall? I'd love to get your input or feedback. Please email me, info@agilicus.com, and check out more information on our website and the links below. Thanks very much. Appreciate your time. Bye-bye.